Hi, Mike here, and I want to talk about volume resistance. So we have three materials, or three forms of our material here. One is it comes out of our twin screw extruder, which then gets granulated, put under very high pressure and extruded into 1.75 or 3 millimeter filament that you use. And then this is a bead of the material that's come out of a 3D printer. And I'm going to measure each one's volume resistance to show you what happens as it moves through the stages and the resistance it has and how we measure it. So first I want to show you that, in fact I'm going to start with the most curled piece. I want to show you that each of these is 20 centimeters long. It's going to be important because we're going to need that to measure or to calculate the volume resistance. So as you can see, you can come close here to this and see if I can get my finger out of the way. There, 20 centimeters. So we can look back here, 20 centimeters. So each of these pieces, each is 20 centimeters. Now, we're going to measure their resistance. We're going to start with the material that, when it's first finished, comes out of the twin screw extruder. And this is a 2.8 millimeter filament. I'm going to go ahead and put the alligator clips right on the plastic with no silver, which actually we typically do, but for this, it will give us a worse reading, but I will not use the silver. And so what we're going to see here, or what we see here, is 170 ohms, say, as a reading. And that is, I'm going to say, across 19.5 centimeters, because I'm using up about 1/2 centimeter for the alligator clips there. So now I've already done the calculations. You can check my math, but as you can see, the calculation for the 2.8 millimeter material is pi r squared for the cross-sectional surface area. And I'm just going to grab this cross-sectional surface area. You can check my math later if you'd like. And I'm going to put that into the width dimension on the calc tool volume resistivity org, which basically uses the formula, which is cross-sectional surface area times resistance divided by length. And so we're going to use 1 as the thickness, so when it multiplies those two together to get the cross-section, it actually gets the right cross-section for a round object, or a round filament. And the length was 20 centimeters, but we're going to actually say 19.5 centimeters. And we had 100, and we're going to say 170 ohms. So the volume resistance for this material, which is actually all the same material, is 0.53 ohm centimeters. Now we're going to move on to the next stage, which is in fact the high pressure stage. This is right before the material gets delivered to you. And this is in fact the most likely place for the material to not be as conductive as the other places. So we will go ahead and put the alligator clips on this. And I'll go ahead and I'm going to squeeze a little bit to get through surface resistance. We're getting a reading of 0.761 kilo ohms, or say 780 ohms. Okay. And so we're going to go ahead and put in 780 ohms, and then we're going to change the cross-sectional surface area to the one that was calculated for 1.75 diameter filament. You can check that later again. And we're going to calculate. I don't know what the answer is here. And we still come out with under an ohm centimeter on this material, which is pre-production, and that is 0.962 ohm centimeters. Now I'm going to move to probably the one you're most interested in, which is what happens when it comes out as a bead. Now, you can do a lot of things in a 3D print to change this by mixing it or putting it inside things. But when it comes out as a bead, that's what we're trying to measure here. Get a good connection on the alligator clip. Come over here. Take the other side. I could squeeze that one to get through. I don't know if it's going to make a difference. Looks like we're not really dealing with any kind of a surface resistivity there. Mostly, that's probably a reading related primarily to volume resistivity. So that's 11.6. So we're going to, again, take the other cross-sectional surface area. We're going to put that in for the smaller diameter. We're going to use the same length, and the resistance was 11.6 kiloohms for that piece, which comes out to 0.71, well, 0.711 rounded up ohm centimeters. So we've gone through the material before, well, when it's finished out of our twin screw, when it's in filament. Now I can tell you when you try this, it's the hardest one to get through the surface resistance on and to get a good reading on. But then as a bead coming out of a 3D printer, that's how we calculate volume resistance. That's what we mean when we say under an ohm centimeter. And hopefully that answers